Good evening, everybody. Hopefully you can hear me. Hopefully you can see me. Welcome again to another general database office hours session. I'm your host, Connor McDonald. Before I go too much, I just need to sync my audio for the recording. So apologies for that. That'll help me later on when I have to post-process this and turn it into something useful on YouTube. Welcome as always. Thank you for giving up your time. I get paid to do this, so I'm always appreciative of you giving up your time to hopefully get a lot of benefit out of this and continue to make yourself more successful with your workings of the Oracle database. We got a chunk of questions to go through tonight. It's been an up and down time inside Oracle organization since the last office hours. I'll get to that once we share the slides. But yeah, hopefully you're all going well. It seems to be we're coming out of some of the nasties we've been having for the last couple of years. But without further ado, let's share my screen and we'll get into the slides and the questions and the content. Okay, sing out if you can't see the slides. And as always, I do my best to keep the chat line open. If you see my head swing that way, it means I'm looking at the chat window. So feel free to use the chat or the Q&A. I almost prefer the chat than the Q&A because in that way, anyone else wants to jump in with answers or opinions or recommendations, we can make this into a much more interactive and enjoyable experience, hopefully for everybody. Getting in touch with me is easy. As you can see, I have modernized this slide. There's now a QR code on it. I took inspiration from the fact that in Western Australia now on our phone, wherever we go, we have to check in for COVID contact tracing, and that's done with a QR code. They're everywhere now in Western Australia. So if you want to get in touch with me via Twitter, blog, YouTube, podcast, etc., you can just scan that QR code either now or when you get the video recording afterwards. For anyone that's new to office hours on my sessions, I always say do not adjust your set as a pun. The slide content is always down toward the left, such that when we turn this into a YouTube video, it will appear on the right or on the right sort of side, top half of the screen, therefore giving it a little bit of balance. So as I always do, a few bits and pieces, things that I think are interesting that are coming up or have just completed or just worthy of note from the Oracle community. Number one is Kscope is on its way. It starts, I think, just in a couple of days' time. It's a fantastic event. We call it ODTUG, the Oracle Developer Tools User Group. It's no longer focused exclusively on Oracle development tools. It covers a huge gamut of technologies, EPM, Apex, database, you name it, analytics, it's all there. And I think there's like, several hundred sessions going on. So I know it's not free, but for the kind of content you're going to be getting, it's, I think, an absolute bang for your buck. I'm doing a couple of talks. One on physical design, the long lost art of physical design in your database, and just demonstrating why it can actually really transform your application performance. And the other one is on the common mistakes. We often talk about all our successes in our development careers and DBA careers. I'd rather talk about things where we go wrong because that's a very useful way of learning and progressing. Also, as always, just a shout out to my own local user group here in Australia. We've got a series of webinars going on throughout the winter months here in Australia, probably summer for most of the people on the call. Lots of cool content there, very much development focused, a lot of Apex content as well. I think the next one might be Karsten from the Apex team talking about the awesome new map features in Apex 21. Literally just grab a table with some nice geometrical points in it, either in the spatial option or even just latitude and longitude points. And bingo, you've got a map sitting in Apex with no more plugins, no more JavaScript, etc. Very, very cool. Here's an interesting bits and pieces for you. You may not have seen this one. This is a freshly public document from inside of Oracle. This is the release schedule coming up for the next decade or so. You can see there that 21C is, or let me take a step back, 19C is the long-term support release or extended support release, probably the best way of describing it. It's similar to the 11G release 2 kind of release in the sense that it's designed to sit there and get continuous security patches, continuous bug fixes for a long, long time. So for those of you that like grabbing a database version and sticking with it, the kind of people that do those blogs, the best database was 7.3 and I'll never move on. things like that, 19C is your go-to release. It'll be supported for the best part of a decade. 21C, which is now available on our cloud and very soon coming to a on-premise release near you, is an innovation release. So it's about delivering features as fast as possible to customers that desperately need leading edge features, but it is a shorter term release. So in terms of support, so be aware of that. If you're a business that happily upgrades on a more frequent basis, it's perfect for you. But if you're a business where upgrade budgets, for example, and scheduling is very hard to do, 19C is where you want to be. Now, this is the reason I wanted to bring this to your attention. Let me highlight something. Unless my mathematics is poor, you can see there will not be a 22C. That got announced internally to us just recently, and now I can share it with you. There won't be a 22C. We'll go from 21C to 23C, and 23C will be the next major long-term support release. So I suppose what I'm saying is, if you need the cool new features in 21C, e.g. blockchain, some of the new PL SQL functions, SQL macros, for example, a lot of the cool stuff, there's a myriad of 21C features out there, then that might be a release you want to jump to. But be aware, if you're the business that, and I think this is probably the majority of us, that likes our upgrades to be as few and as far between as possible, be aware that you really want to be on 19C such that you can just sit on that one for as long as you like, and then the next jump you'll make will be to 23C. There will not be a 22C release. And you can see that the 21C and the 23C cut over there is fairly tight. So if you are on 21C, then by the time 23C comes out, you'll be almost expected to go to that release relatively quickly anyway. As always, all of these dates are subject to change, because the first thing that people raised when they saw that was like, gee, that's a sharp, cutover point for the 21C customers. So I wouldn't be surprised if 21C support maybe drags a little bit more than what you can see on that chart there. Don't quote me. Everything here is subject to change, but I just wanted to let you know it'll be 19, 21, and the next release will be 23C. So someone put in the chat, where's 2022C? It ain't there. Just a shout out once again, I did one of these during the month, so I thought I'd put a little advertisement out there. Office hours are questions from the community that I pick and choose. I sort of cherry pick the ones that I think you will find interesting, and I present on this office hours segment. Obviously, if you want something which is dedicated just for you, for your own IT shop, we can do an office hours dedicated for you with dedicated topics of your choosing, and we'll find the right expert to do it. So if you want that, please reach out. As I've always said at office hours, obviously we're in the middle of still a pandemic. We're hopefully coming toward the end of it, but if in particular, India's been going through a bad time. So wherever you can help out, please do so, whether it be financially or just giving some support to others in the community. We have a huge Oracle community in India, so please reach out wherever you can. And obviously, this is our path out of the pandemic. Let's get vaccinated because we want our communities to be back. I must admit, I'm almost sad. I shouldn't say that. I'm almost sad when I see the great news of call for papers coming out now for in-person events around the world. The reason I'm sad is I won't be going to them because in Australia, it's unlikely we'll be flying internationally probably till mid next year. But I shouldn't be selfish. I'm thrilled to see that in-person events are on the way back, which means we're clawing out of this. Just one thing I wanted to touch on, I know this is chewing up a bit of our office hours time, was I said it was an up and down month inside the Oracle Corporation. We lost a giant, not just from inside Oracle, but a giant of the Oracle community last month. Joel Kalman, Apex, I think a senior vice president, but just one of the founders of Apex. If you go look in the Apex installation, you'll see that generally it says J. Coleman at the very early instances in the version history of so many of the Apex scripts. Him and Mike Hitchra and Tom Kite and a few others were the sort of the founding members of Application Express. We lost Joel due to COVID. I put a QR code there for the YouTube video. That was the last Apex office hours that happened just about a week ago, and they put the Apex team obviously really hit them hard, but they put some beautiful thoughts together. So I'd encourage you to watch the last 20 minutes of that office hours video just to get their thoughts on Joel. I just wanted to share a couple of things on Joel. This is probably my best summation of the man. At the open world, last time we had an open world in person in 2019. Sorry, that was my dog barking at me. Last time we had an open world in 2019, we did the Across the Bridges run. We're all looking for Ubers on the way back to the hotel. And of course, Joel says, please jump in the Uber with me. And ACE director, Rita Nunez, also jumped in as well. First time Joel had met Rita. They struck up a wonderful conversation, as Joel was always pertained to do in the Uber on the way back to the hotel. And then he get out of the car and Joel says, I've got to get a selfie because I need to remember the first time we met, because I'm sure we'll be meeting each other again soon, because Rita is so active in the community. So even that was a touch. And I took that photo. And of course, the first thing Joel says is, you can't be left out. And he then took a selfie of both of us as well. So that's just a measure of the man. And he was just always a giving and supportive person for the Oracle community. So we'll all miss him. And I sort of apologize, but I wanted to take a couple of minutes just to remember someone who gave so much to the community and is hopefully a mentor for all of us to share our knowledge and share our generosity with the community. On a more uplifting tone, let's get into the content for tonight. We'll try to get through all these things if we can. Migrating from UTL file directory, that was a topic we didn't get to last month, but we'll cover it first up this month. Bloom filters, how to work out the SQL ID from a piece of SQL text. The risks with having indexes. This is a question that came out of my podcast. And the limitations of hash joins. So let's see if we can cover them off in this session tonight. What I have done to try and keep it quick is a couple of these things, rather than having real demos, I've just put the code snippets in the slides so we could move through them a bit more quickly, just to hopefully get through all 5 in the time available. Number 1, UTL file dir migration. What do I mean by UTL file dir? Well, this is the question that came in. We read and write a lot of files in our database, and they do it with the UTL file built-in package. They do it to a complex folder subsystem, and to manage that, or to allow that in their existing database, they've simply set the initialization parameter UTL file dir equals asterisk. Now we're getting ready to upgrade to 19C, and UTL file dir is desupported. What are our options? For those that are new to the database, when UTL file, the package first came out, UTL file dir was a parameter you set, and you simply put a list of directories that you were allowed to write to. It was a way of controlling and securing the database server, because obviously it's a fairly precious resource. However, we did allow wildcards, and what people would do is, because you needed to bounce the database to change UTL file dir, that upset people. They said, let's just solve the problem once and for all, and they set UTL file dir equals star, which means you can write anywhere. This customer is migrating to 8 to 19C, but I should stress that it literally is from 18C onwards. You cannot use UTL file dir in any way, shape, or form as an initialization parameter, which also means the directory parameter that It also means that the directory parameter that goes into many of the UTL file packages, UTL file open, close, etc., must be a directory object done with the create directory command, not a explicit file path. Now, before you jump on the chat line or Twitter and saying, it was, damn Oracle, why did they take away such a useful thing? Let's explain why UTL file dir equals asterisk was a really bad idea. UTL file package runs as PL/SQL, which means it's running as the Oracle user inside your database, which means it has the same OS permissions as the Oracle user inside the database. So if you were, as maliciously minded as I tend to be, you could write yourself a little script like this. We loop through doing some sort of interesting regular expressions against $data file. And with each row that comes out of that cursor, I do a UTL file dir file open. File open in write mode means whatever is there, erase it and initialize it with a file of 0 size. Now, what is the output from that actual SQL cursor I've got there? It's this. Using some regular expressions, I'm simply getting the path name and then the file name to use as directory and file for each of my data files in my database. And I ordered by file number descending because that way I'll simply loop through all the user data files and I'll open them with a UTL file open, which means erase them and set them to 0 bytes. And there's a good chance that'll keep on going because the last one I do will be the system table space. And at the end of that, my database is remarkably efficient because it's no longer of any bytes in size, but all my data is gone. This is the kind of exposure you are at the moment you get UTL file dir equals star. Even if someone couldn't query $v data file, if they could take some intelligent guesses as to what critical files might be on the system that are owned by Oracle, they could literally just hose your system. Let's face it, most of us use the OFA standard for our Oracle software installations. So it wouldn't take a hacker or anyone malicious inside your organization long to think, well, what I can do is I can simply take a guess as to it's probably under /uo1/app/oracle, etc., and wipe out the Oracle executable. So UTL file dir equals star was always just a catastrophic idea. What I'm suggesting is, if you don't want to have to re-architect your application because it's got heaps and heaps of calls to explicit file paths, you can introduce an interception layer. And here's a little package I thought I'd simply walk through, and I'll put this out of my GitHub account so anyone that wants to use it can do it. Let me do a new share. Did I call it this? I hope so. So here's our existing customer. This is their current predicament. This is what they used to be able to do. They could connect as their normal user, and this is the kind of flexibility they used to have. I could simply say, yep, just go to any particular folder that I have existing on my system, open up a brand new file there, and write to it. Now you can see I haven't actually run this because you can see I haven't actually run this because while that will work fine in versions before 18C, where I've set util file dir equals star, the moment I try to in a current release, I get invalid directory object because the first parameter can no longer be an operating system path. It must be a directory object. So the challenge here is, how can I keep this code looking as close as it can to this, as we see here, where I'm simply freely using file names or file paths, so I don't have to refactor all my application while I'm still restricted by using directory objects. So I'm going to connect now as a DBA user, which is me in this case, but effectively an administrative user. And this is what I'm going to do. I need to make this window a bit bigger so we can fit it all in. I'm going to create a function called util file dir. It's effectively a drop-in replacement for my util file dir parameter. And this is what it's going to do. You'll pass in an actual operating system directory, just like you had before, x:, or on Unix it would be /something/something/something else. You'll simply drop it in. What we're going to do is effectively have a little bit of playing around with this to see if we can find an existing directory object that matches to it. Now, if the thing they pass in has no delimiter whatsoever, it probably means we're actually passing in already a directory object, and that's part of what this thing will handle. But if I can't, what we're going to do is actually dynamically create a directory object on the database based on the operating system path name they've passed in. And I had just a quick run at this. So for example, in this case, if you actually had two different folders, U app Oracle and U app Oracle with say a dash in it, they would, in my code here, that would map to the same name and you would get a bit of a problem. So it's designed to handle the basic cases, but you'll obviously take this and make it as robust as required for your system. But what's going to happen is if you pass in something like U app O1 Oracle, I'm going to dynamically create a directory object which looks like U01_app_oracle, and I'm going to add a bit of hash at the end just to hopefully keep it as unique as possible, such that if other directory paths come in that are very similar in terms of an operating system path, the hash function will be just enough to actually make it unique throughout. Because directory names are obviously limited to just 128 characters as a database object, whereas operating system path names could be far more. So here's the little bit of regular expression to try turn a operating system path into a directory object name add a little bit of hash function as well to see how we go, and then add it pops out. I've also put in here is it was sort of somewhere in here, we would perhaps, let me scroll back a bit. Somewhere in here, you could actually add some sanity checks. So in the same way that we don't want anyone with util file dir equals asterisk actually passing in data file names, etc., because we're adding an interception layer here can't speak tonight. Because we're adding an interception layer, in this code here, we will do extra checks, things like, are you going against the software distribution? Are you going against, for example, the audit directories? Are you going against the data files, etc.? So we could do extra checks here, but there's our function. Now I can execute on that function back to my normal user called Scott. Now what I'm going to do with Scott is actually create his own copy of the standard UTL file package. So the package header is literally straight out of DBA source. So I'm simply creating in my Scott schema my own version of UTL file package. And the package spec is literally exactly the same as what you had in the system version. It's just a wrapper around it. So there's nothing different here. That's the entire package, literally a one-for-one copy of what was in the sys schema. The package body is where things are going to change. Now, obviously, I don't want to re-implement UTL file from scratch. All I'm really going to be doing is doing calls to the standard UTL file package. So fopen, rather than just passing in the directory, the location that you gave me, what I do is I take your location and put it through my UTL file dir function. So if you pass in me an operating system path, this will either return an existing directory object that maps to it or dynamically create one and then return it anyway. And then we just go ahead and call standard UTL file. And in fact, anywhere in this UTL file version where I need to reference a directory, for example, file open nchar, I'll simply intercept it with my own function here, which maps operating systems to real directories. If it doesn't, if I don't need to reference the directory, I simply call UTL file in the normal way. So, yeah, someone said, unless the name contains a double quote. So yeah, so you're right. As I said before, I've given implementation here, which is a reasonably good approximation as to how we could do a nice directory object here. The reason you can't just do a one-for-one is because we have limits on how long operating system paths are, which are much longer than the directory object, but a very good point. And so the rest of it is pretty much wherever I have a location or a directory inside Oracle, I intercept it so I can convert it to a directory object. Otherwise, I just ignore it and just call sysutl file anyway. As a result, now when I call my original piece of code, which still looks like it's referencing operating system paths, it looks exactly like the previous code which worked out of the box in version 11, version 12, it now runs. And just to prove it, if I actually check what happened here, it said, yes, you tried to reference a directory path called this. I dynamically created a directory called xtemp util file data with a hash at the end. And we can actually check that actually folder on this PC here, we did successfully create a thing called emp.dat, and there's the content. So it can be done. That's a nice way of actually having your existing code base, almost no changes required because we are dynamically intercepting your usage of operating system paths and mapping them to directory objects. One of the things I did was I could also extend this. So for example, I could do things like if someone actually tries to pass in effectively a directory object directly, I could simply return it as opposed to raising an error. I suppose the point I wanted to put here is you can put whatever you want into this interception package. As I said, you could do extra validation checks. You could add auditing. Why are people using these particular paths? I could add exceptions where I simply say, okay, from now on, I need you to start using directory objects. Otherwise, I'm going to start giving errors. So it's a way of slowly letting people refactor their code to being directory objects. And the whole time, you're not having to do a big bang refactoring of all your code, but you still get access to whatever complex subfolders and structures you want. So that's the interception layer, which I think is a cool idea for letting people continue their existing code base, but also get the added security of moving to directory objects. And as I said, you can augment it, add it in any way, shape, or form. I'll put the source code for that. I think it's already out there on my GitHub account, so feel free to grab it. As always, anything on my personal GitHub is, use at your own risk, but I had a bit of a play with it. It seems to work pretty well, and hopefully it helps you ease that migration from pre-19C to 19C for that long-term support without having to rewrite lots of your code. And as I said, you get the bonus of much, much better security and data protection in your database. Please tell me it's not 9:30 already. Good, 9:26, we're doing okay, sort of. Bloom filters. Here's the question that came in. I consider myself reasonably good at reading an execution plan, and I'm glad you do. Most of us do as well, which is great. However, a colleague asked me to explain the BF section in a execution plan, and what does BF mean? So to explain that, let's start with an example, and we'll work our way back to Bloom filters, because this is probably one of the most common places you'll see it. One of the cool things with the partitioning option in the Oracle database is this thing called partition pruning. So if I have a table called sales, and we don't have to look at the syntax too carefully, all we have to be aware of is that we've got a partition for each month. And I've defined them here. This is not an interval, it's just a straight out. Here I have a static list of partitions, one for each month. The cool thing with partition pruning is that you manage to avoid having to scan great chunks of data. So if I do a query here saying, show me some data for a particular day in July, you can see the execution plan tells me I'm only going to scan the partition for July, the 7th partition. Partition start, partition stop is 7. And partition pruning is pretty good. In this case, I've immediately avoided having to scan 11 months. But it's got some awesome, if it's a bind variable, it still works. It won't tell you what the partition is because it doesn't know until you actually pass a bind variable in, the actual value, but it will tell you that, yes, I'll be doing just a single range partition, just one partition, not the whole table. And the key is I'll work out when you actually come to execute it. But there's enough there in the plan to tell me that I'm getting what I want. I'm getting partition pruning. Even when you do things like in. An in clause, it says, yes, I'll be doing a partition range in list. So whatever those two values are, unfortunately, the partition start and stop isn't good enough to show you what the explicit partition numbers are. It's just a limitation of the execution plan output. But in this case, we'll scan the June partition and the December partition and skip all the others. When it comes to subqueries, though, and joins, things get a bit more complicated. If I look at this query here, you can see, well, out of the box in a non-partitioned arrangement, I would simply have to scan the entire sales table and the entire employee table, obviously, because employee is not partitioned, but sales is. But ideally, we'd like to not have to do that. Wouldn't it be cool if we could scan the employee table and based on the data in it, decide on how we're going to access the sales table? If we look at the execution plan, this is where we start seeing these strange :BF operators. And we can see what's going on. It says the first thing I'm going to do is scan the employee table. And it says in doing so, I'm going to do a part join filter create. That's a little bit of gobbledygook, but what we're saying is we're actually going to create what's called a Bloom filter, and then we're going to use that Bloom filter in order to prune out partitions in the sales table. So when it comes to these, when you start seeing these things, what does these things mean? What does BF mean? And the imagine is it's a Bloom filter. This is the definition of Wikipedia. I'll have to read this. The Bloom filter is a space-efficient probabilistic data structure that is used to test whether an element is a member of a set. And the good thing is when you read that, I'm going, I have no clue what that's talking about. So I thought I'd give you a metaphor and hopefully a timely metaphor to help explain how this is going to work. A good metaphor I like is what I call phoning in advance. And what I mean by phoning by advance, let me give you an example. There's a movie I want to see. It's coming out, or I think it's probably out already in the States, but it's coming out shortly in Australia called A Quiet Place Part 2, the sequel. It's a horror movie with John Krasinski and Emily Blunt. Cool movie about aliens and monsters and sounds and stuff like that. But I'm keen to see it, but obviously having not been to a cinema for so long, everyone in Perth is like just desperate to go to the movies nowadays because they can finally all sit next to each other. And so if this movie is coming out, it's going to be incredibly popular. So I'm normally going to phone up. I'm going to say, I'm going to phone up. So look, I want to have, I want to get a nice seat in gold class with the big reclining seats, popcorn, the whole, gear. Do you have any seats? I phone ahead and the guy goes, hello, it's the sequel to A Quiet Place. No one's been at the movie for 2 years. Are you serious? There is no way on earth you're going to get tickets for that, mate. Try again in 6 months when we've, the volume has dropped a little bit. And that's why you phone ahead, because I didn't want to have to drive down there and actually then be told, no, we're sold out. Now, he might not have said that. The person that owns the cinema might have said, there's a few seats left. We're not actually sold. There's a few seats left in the session that you want. Come on down. So I jump in the car, and of course, I'll just absolutely hoon down there. Grab myself some popcorn, then I go to the ticket desk, and I'm ready to go. And I get there, and I get rid of my money out, and they go, sorry, we're sold out. Frustrating, I know. But that's the risk you pay. When there's a few seats left, there's a time it takes to get down there in the car, etc. That is what a bloom filter is. A bloom filter is these two things. It's the phoning in advance. The bloom filter is like your mobile phone in this metaphor. You phone in advance and it might save you a drive. So the bloom filter can definitely tell you that you can't get tickets, or it might tell you there's a chance, but it's not a guarantee. And so in more mathematically correct terms, what we're saying is when data gets put through a bloom filter, you might get a false positive. You might, if you're trying to see if some data is, I need to act on some data, putting it through a bloom filter, it might say, yes, you need to do some more work with this data, but in reality, you don't. It doesn't apply, for example, to a join condition. However, with a bloom filter, false negatives are impossible. If the bloom filter says, nope, you don't need to do any more work with this data, you can guarantee that that is not the case. And the way a bloom filter works is you have some incoming data, and it runs through multiple hash functions, and those hash functions basically return bits. And what you're doing is building up a bit mask segment in memory, and then you use that bit mask to do comparisons to other data structures. Now, to help explain this, I found this cool website called jasondavies.com/bloomfilter. Unfortunately, the website the demo is like it's a GIF, and it's a tiny little GIF. So hopefully you can see that, but I'll read it as we go. You can see down the middle here is our little bit mask. And what I can do is at the top left here, I can actually type in values that I would like to put through my bloom filter. It's going to put whatever data in there through 3 functions, and each one will return some positions in that bit mask, and it'll set them. So let me play the video, and I'll read it out as we go. So I typed in A, and they're the 3 bits it set for A. Then B, and then C, and then D. And each time you can see that the 3 hash functions create various spots in the bit mask. So each letter is being applied to 3 hash functions. That's why you can see 3 arrows coming out of each of these things. And I go all the way down to J. Let me pause here. So I've got an incoming set of data, the letters A through J. Each one's been put through 3 hash functions. Each of those hash functions returns a position in the bit mask. And so you can see I've sort of colored in sort of a chunk of these bits. Now I'm going to see I've got some data on the other side of my bloom filter, and I want to see if the data I supply here is one of these, A through J, because effectively I'm doing something similar to a join here. So the first one I do, I can't remember what I'm there. QW doesn't, it says it's definitely not there. I type some other stuff. What do I try next? There's a pause here. I type in R. The 3 hash functions don't match. S doesn't match. C doesn't match. 1 doesn't match. 2 did. If we look at the hash function results for the number 2, they hit that yellow one, and that yellow one. So this is one of the examples of a false positive. A bloom filter has correctly said R's not in there, Q's not in there, V's not in there. They're all definitely not in there. But then it said, 2 might be in there. So you would actually have to grab this value 2, go over here and actually see if it's there. But you can see the bloom filter has saved me some work. I didn't have to take my value of R over here and go check this list here. there's a whole, in fact, if we keep playing it, you can see there's a whole stack of things here. It's going to go, yep, probably not there, definitely not there, definitely not there, etc. It continues onwards, and all these values that say definitely not there are bits of work that I've saved. I didn't have to go over to that side of the data and look and see if that data is actually present. So already you can sort of get an idea for how joins could be improved, because we put the data through a Bloom filter and can definitely decide we don't have to go compare it with the other data set because there's no way it can be there. Hopefully that video helps explain things a bit. So how does this apply back to partitioning, and why is Bloom filters very, very useful for partitioning? First, as I saw in that execution plan, I scan my employee table. And what I'm going to do is I'm going to take the year from my hire date, which is the join column I was using. I can extract the year from the date, and I can put the year into a Bloom filter. So as I go through the data, the Bloom filter might fill in these particular bit masks. I've been very, very simplistic here. Then I can take not the partition table, but I can take the dictionary definition for the partition table, because I know from the partitions what years in this particular case. In fact, I think my DDL is for a month, wasn't it? But bear with me, this is for years. We'll go with years here. My partitions for a given year, I can take each of those and put them through a Bloom filter as well, and I might fill in a few more dots. But the ones that line up tells me that these are the only partitions I'll need to scan. By putting the partition definitions through a Bloom filter and equating it to the smaller table's actual data values, I've managed to prune out my partitions. I know that only this one, which is 2015, this one 2019, this one 2020. Therefore, I only have to scan 3 sales partitions. So I'm doing partition pruning by using a Bloom filter to sift through the data first. That's why they're very, very cool. The general case for a Bloom filter is I have a set of data on this side. I want to see if this data is in this piece of data here, this data set here, but doing that comparison is expensive. And in a database, generally this means it could be an expensive join. This could be a massive data set with no easy way of scanning it through. So anything you can do to try improve the performance of that is where a Bloom filter gets useful. You put a Bloom filter on this side, and then you come up with some mechanism of hopefully avoiding having to scan this as much. So it's not just partition pruning we use this. We use it in things like parallel query slaves, because parallel query slaves, as you can imagine, you take one table, you have lots of worker threads scanning different chunks of the table. And then if you're doing a join, you have other parallel worker threads scanning the other table. Now, normally, if you had, say, 3 worker threads here and 3 worker threads here, well, this guy has to check all 3 of these, as does this one, as does this one. I should have put this in a diagram. Using Bloom filters, we can eliminate the amount of messages that have to go between those parallel worker threads to try sort of prematurely eliminate data from consideration. Exadata offloading, another great example. In an Exadata system, you have a database node and you have a storage server. And between them, you have InfiniBand, or in later versions, 100 gigabit Ethernet. Doesn't matter how good your network is, it's expensive to go across a network line to do data. So you might be able to make some decisions as to what do I have to get back from the storage cell using a Bloom filter, or what do I have to pass down to a storage cell using Bloom filters to eliminate the amount of traffic going across. There are so many smarts in Exadata. The other one is in memory. When we're doing in-memory joins as well, the scanning of data in memory is so blazingly fast. Anything that's different to just scanning in memory and going back to what I'd call conventional database stuff, joins, etc., is orders of magnitude slower because the RAM is so quick. It's really, really expensive to do join comparisons compared to just reading these incredibly fast RAM structures in memory. Therefore, once again, Bloom filters to try reduce the amount of data to join to get the true benefits of the in-memory subsystem. There's lots of other examples as well, and I wouldn't be surprised as time goes on, you'll see more and more Bloom filters in your execution plans, and they're obviously nothing to be scared of. If you want to do a deeper dive into Bloom filters, ACE Director Christian Taganini has done some PowerPoint presentations on this. They're very cool. and go to the DOAG site. It's a public document, and he's got a lovely presentation there on bloom filters as well. Okay, next one. Okay, a question's come in from Rachel. What about joining 5 or 6 tables which have 2 to 10 million rows each? Okay, I've got some bad news, Rachel. Oracle will only ever join 2 tables at a time. Now, let me explain. If you have a 5-way join, Oracle will join the first 2 tables, end up with a result, and then join that to the 3rd table, end up with a result, 4th table. So we always do joins in pairs, and a bloom filter could assist during that process. Now, I'm being a little bit flippant here, because the one exception to that is what we call nested hash joins. Theoretically, it's actually still true as just doing effectively pairs of joins at a time. However, you get the feeling that they're all happening at once, because what a hash join can do is start producing output as the join is progressing. Unlike a sort merge where you have to sort both sides, do the join, and then you get the result, with a hash join, after you've read the first side of the join and start joining to the second one, you can start spitting out results. They might be inputs into the next hash join. And so very quickly you see this hash, 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 hash in your execution plans. And it looks like they're all running at once, because data can actually be coming out of the first join and going into the second, and coming out of that and going into the third, etc. But the actual operations themselves are always just between 2 sets of inputs. And you can use bloom filters to hopefully improve the performance of that as it becomes potentially an input into the next join. Hopefully that explains that. How to get the SQL ID? Here's the question that came in. Obviously, whenever we are SQL tuning, the SQL ID is just about the most important thing that you have to know. And it's the thing we often do with SQL tuning. You go querying $SQL or $SQL error, $SQL stats, etc. And you look for stuff which is expensive, and then you find the SQL ID. Because once you've got that, you can go get the plan, etc. It's obviously like, it's almost like the primary key to SQL text in the library cache. This customer has an application that, after I had a bit more of a chat with them, creates dynamic SQL. They have an ad hoc searching facility, and it dynamically creates SQL. What they want to do, which I think is a very cool idea, is run their SQL that these users have created on the fly, find out the SQL ID for that SQL, go query things like SQL stats, SQL, to find out what the buffer gets were, what the disk reads were, what the parsing time was, etc. So they can actually capture some performance metrics in real time in the application itself, not doing things like separate tracing, etc. So I think it's a very cool little idea. The question is, if you have a piece of SQL text, how do you know what the SQL ID is? We can get very, very close. In fact, I'd argue that we can actually do better than the SQL ID, which sounds almost impossible, but let me explain. And I think way back in Oracle 12, we added to the DBS utility function the get SQL hash function. Let's see how it works, because it's a little bit cryptic. So I'm going to start in reverse. I'm going to start with a known SQL and a known hash value. I'm going to select 99 from dual, very, very simple SQL statement, run that, and then query it out of SQL that says the hash value is 835.694, etc. The question is, does DMS utility get SQL hash value give me that back? And the answer is no. So let me explain why. If you just pump it in like this, there's my SQL text, get SQL hash, you get an answer which doesn't appear correct. For reasons I will never know, you have to take your SQL text and append a CHR0. Now, anyone that has ever worked with things like C, that's the end of string typical terminator. Why you have to do it here, I don't know, but you do. You have to add CHR0. Once you've done that, get SQL hash will return you this, which looks nothing like the hash value you just saw on the previous slide. That. But believe it or not, they are one and the same. Let me explain. When this comes out, this is actually the full SQL hash value that is used internally inside Oracle. In fact, in some parts of SQL Trace, you'll often see the SQL ID for example, dynamic sampling is this huge, big, long decimal number. The SQL ID is just a shortened and a shorthand version of that, as is the hash value you see from $SQL. This is the genuine hash value that is being used in the library cache. What we do is we take the last 4 bytes, or the last eight pieces of hex characters, take them and convert them to decimal just using 2 number, and you actually get the hash value. So it is in there, it's just the last piece there. So when you see the hash value in SQL, it's actually just the trailing bytes. It's not the genuine hash value, but it's enough to uniquely identify it for you. So that lets you get the hash value out of there. Thus, grab a piece of SQL text, append chr0, put it through that function, grab the last 4 bytes, turn them into a number, and there's your hash value. You can now get it out of SQL once you've executed your SQL. Now, why am I saying the hash value, and not the SQL ID? Because you can actually derive the SQL ID out of this. The SQL ID is actually the leading, I think, 16 bytes, the leading 128 bits, might be 8. And you take that, you convert it to base 32 using a sort of a bit of a cryptic thing. You might be thinking, is base 32 a real thing? Yes, it is. It's an interesting thing inside Oracle, which is the 0 through 9 plus most of the alphabet, not all of it. So that's why I didn't bother doing it here, because we don't really need it. So the SQL ID is just a variant of the hash value anyway. So the hash value is the genuine thing. SQL ID is just a nice human readable version of a hash value anyway. You may as well just use the real numeric hash value. It's probably going to be more efficient to dive into those $V structures. But there you have it, dbmsutility.getSQLHash with a little bit of perturbation will give you that numeric hash value, which you can now query directly out of $SQL, $SQL stats, $SQL area, etc., 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 $SQL plan. So once again, I really like this mechanism of this. I really like this philosophy of having an application dig into performance metrics about itself, not leaving it to some poor DBA after the fact trying to work out what's going on. I think that's a very, very cool piece of technology this person is building. If you want some more reading, Tanel Poda's got some nice stuff on converting SQL IDs to hash values, and another blog post there as well. You'll see them in the video afterwards. Yeah, some cool stuff there if you want to check out the internals of hash values and SQL IDs and the intricacies of base 32 as well. How are we going for time? 9:48. We might get there. Risks with indexes. There's a very good reason I put this question in here, because it came from someone who was listening to my podcast, which of course gives me an excuse to shamelessly plug my podcast. So just any podcasting platform, look for the Spoken Nerd and you'll find my podcast. But enough shameful advertising. I was listening to your podcast. Did I mention my pod? No, sorry. I was listening to your podcast and you repeatedly said, people seem to be unaware of how high risk it is to add an index on a system. Can you elaborate on that and how to lower that risk? Let me explain why it's risky. This is the thing that blows my mind when people go add indexes on their system, is you might have a piece of SQL that's performing poorly and you want to actually, put an index on it to make it better. I know of almost no systems, in fact, I'm confidently saying no systems, that have a table that only has a single SQL run against it. In fact, the only tables that do so are typically so small, they're reference tables, and the only thing you ever do on it is a primary key lookup to get some metadata. But primary keys are already there. We don't need indexes on those tables. The only tables we ever need indexes on generally are the larger, more actively used tables. And rest assured, there is normally a myriad of different SQL statements that run against those tables. To focus on just one of those queries and say, let's bang an index on a table, means you could have literally changed the entire performance profile of your application in the blink of an eye. You could have made 100 SQL statements dramatically faster, and you'll be a hero. But you could have also made 99 statements dramatically slower, and you'll be a villain. And it seems an incredible, risky roll of the dice to do that. just because you have one statement that's running slowly. And in fact, one of the whole design patterns behind 19C's automatic indexing was an acknowledgement of the incredible risk in building indexes. And unless you've been living on another planet, you've probably seen this pentagram or about how 19C automatic indexing works. We find bad SQLs, we put some indexes on without actually building them. We see if they're going to help the optimizer. If they do, we go build them as invisible. Then we actually do some test executions, and then we actually activate them. And it does this every 15 minutes. It does it with all sorts of impressive smarts. It tries to consolidate indexes. It monitors them for use. It'll drop them if they're unused. It's an incredibly cool piece of tech. So we can follow its lead in terms of trying to mitigate the risk, whether you're on 19C or not, whether you get access to automatic indexing or not, because predominantly it's on the autonomous systems and Exadata. If you follow its lead, you can actually hopefully get close to that similar kind of arrangement where you're minimizing the risk of adding indexes. And this is the typical scenario you're going to face. Someone's going to come to you, whether it's a developer, DBA colleague, etc., and they're going to say, look, we got a query on my 6 terabyte table. It's running really, really slow. I've got an idea for an index. And being cautious as we are as IT professionals, your response is probably going to be, is it definitely going to speed things up? And the response you're going to get is this: I think so. Now, this is not me crapping all over the person who was asking for an index. The reality is, back in the day when databases were smaller and budgets were bigger, we would have a 100 gigabyte production database, and you'd have a 100 gigabyte test database and a 100 gigabyte development database. People understood the importance of having real-sized non-production environments to do performance testing on. Nowadays, in these great worlds of continuous deployment, continuous delivery, every developer has their own database, etc., the enormous benefits of that flexibility and turnaround time have come with an enormous drawback as well, is that we generally don't get full-size testing environments. So I fully defend any developer that says, all I can do is I think so. Because it's so hard for them nowadays because we have these enormous production databases and they never get a similar size one to do any kind of performance testing on. They have their own little sandbox, etc. That flexibility has come with that price, that we don't ever see performance problems until production, which is obviously not the best time to be seeing them. But one of the things you can do is a thing called virtual indexes. Now, I stress this is not supported. It's actually a facility that's used by Enterprise Manager back in the day to see if indexes should be added. But you can actually take advantage of it. Just be aware that it is unsupported. You're on your own here. You can create an index on a table and specify this keyword called no segment. And what that does, it creates the database dictionary entries for that index. It'll be in user indexes, user in columns, etc. It's all there. The only thing that's not there is the index data. It doesn't go build the index. The index looks in the database like it exists. You can think of it like as an unusable index. It's simply there by definition only. Of course, you can't use it. It can't be used for performance benefits. So what's the reason we have one? You can now go and run a generate stats command. Notice this is not gather. This is a generate stats on the table that you just created that index on. It uses the statistics on the columns and the tables to come up with a representative state of statistics that would be there on that index. That's why we call it generate stats, not gather. It looks at the number of rows in each column, the number of rows in the table, and says, okay, based on that, the index stats for this fictional index would probably be this. Obviously, you can't really use this index yet. But what you can do is you can tell the database to generate an execution plan as if that index really existed. And I do that by doing this setting, alter session set use no segment indexes equals true. Then I can run an execution plan. Here's my query. And I can see, is my new index going to be used? And this is critical because don't forget, just because an index is there doesn't mean the optimizer is going to use it. And it will be a terrible waste of time to go create an index on a 6 terabyte table for the optimizer not to use it on your query anyway. So in this case, this is a great way of getting a good level of confidence that if I go ahead and spend that time building this index, the optimizer is indeed going to use it. So I like this. This is a risk mitigation strategy. Similarly, you can now run other queries in your system on this same table that you don't have any performance problems with to see if they'll use the new index. Because if they do, you might introduce a regression. If they don't use it, once again, you have that confidence that they're actually not going to be impacted. So I like this idea because it costs you nothing. It's simply a data dictionary definition. It doesn't cost you anything to do anything. Some additional mitigations. Once you've done this, then you can actually go ahead and build that index, but build it as invisible. By building it as invisible, no other session can see it. And you can actually add a hint. I think it's called use invisible index to just the query that you want to improve. Therefore, once again, mitigating the risk of other queries being impacted. You can also set that at session level using an alter session. You can say use invisible indexes equals true. So it's a nice way of being able to, once again, make sure that the index you just built doesn't, wreak a path of destruction to the rest of your application. The other thing you can do is evaluate the scope of impact. This is one of the queries I like running if I'm going to create an index. I'll do select, go get all the SQL statements that reference my table, this table called emp. If I'm going to create an index on the table called emp, I want to find every existing SQL statement in my application that currently accesses the emp table in VLL SQL plan. By doing so, I can then say, okay, let's now do that testing against each one of those. Or I could do something the other way around. I could use SQL plan management and say for every single statement that references that table that I'm not tuning, I'm tuning this particular one over here, I'll use SPM to lock down the existing plan for all of them, except my problem statement. Therefore, now when I make that index active or visible, it doesn't matter because none of these people are going to use it anyway. And then I can once again, over time, go look at each individual one, decide if I want to ease up that SQL plan management plan. If that sounds like a cool idea, that's exactly what automatic indexing does. It uses SQL plan management to ensure we don't get regressions. So hopefully that makes sense. We got 3 minutes left, and this one isn't that long, so I think we will get done. Okay, a couple of quick questions. So I just want to know that the people who are asking questions, these are the people you can blame for when we run over. It's no longer my fault. Can we use select DMIR SQL translator, SQL AD, SQL text from Dual? In terms of can you use, I'm not entirely sure what do you mean by can we use. If you mean dynamically adding a hint such that we use invisible indexes, pretty sure you can. I've used SQL translation to literally convert SQL text. There's a previous video on the office hours about converting sysdate to current date, for example. So I'm pretty sure you should be able to use that. What happens if an old view includes a hint to an index, which the 19C automatic indexing drops? Just like any other index, it will not use that index anymore because it no longer exists. You won't get an error, but just like an invalid hint does nothing, a hint to a non-existent index also does nothing. By the way, I should stress that in automatic indexing, the default operation for dropping non-automatic indexes, as in indexes that weren't created by the engine itself, it's turned off by default. You can turn it on, but we go safety first. In automatic indexing, any manually created indexes that have never been used or not used for a year, automatic indexing will report that, but it won't do anything with them. It just ignores the hint, correct. Okay, last one. Now it's 9:59. That's no good. Okay, we'll get only a few minutes this one. Hash join limitations. This is one that came in on Stack Overflow. I'm doing a not in query and hoping to get the fast hash anti-join, which is a very cool way of doing a non-membership. Hash anti-joins are super fast. But this seems limited to being in only a single column in the subquery. Is concatenating all the columns, if I want to do more, an acceptable workaround? When I read this, my first thought was like, I am unaware of any single column limitation in the not in part that would block a hash join. But let's explore what this person was going with. So I'm going to create a table called T1, create a table called T2. I'm going to put 100 or 1,000 rows into each one, gather some stats. They had the same data in each one, obviously, so we're not going to get any results from a not-in query, but really we're just interested in the execution plans. And so this is the example that came out on Stack Overflow. When I got 2 columns in here, not just 1 column, select star from T1 where X, Y not in, select XY from T2, no hash join. What it does is the merge anti-join, which is generally more expensive because we have to sort both input sets and then merge them together. It's a big slug on your temporary table space. And so here's the question. Then they said, well, this is how I'm working around it. Rather than doing X, Y, I'm concatenating the two. Therefore, it's now just 1 column, so to speak, and comparing it to the concatenation of those. And hey presto, I get hash join anti, which is super cool. So what's going on here? Because as I said, I'm pretty sure there is no limit to the number of columns you can have there. If we go back to the first one that went back to the merge join and try work out why, if we print out more information from the execution plan, in particular the predicate section, you start seeing this, all these internal functions and toNumber and all this kind of stuff going on. This is perhaps a better clue as to why we couldn't do a hash join, because hash joins are generally about pure equality and pure inequality. I skipped over this when I created the tables deliberately. If we look at the table structures, they're actually the same data, but they're different data types. One of them is numbers and one of them is varchar 2. So if I actually take, let me make that a bit wider so we can fit it on. So if we actually take that into consideration and bring all the data types into alignment, tochar on the numerics, then compare them to characters, hey presto, I get a hash anti-join. So there's no limit on the number of columns, but there is consideration, like all things Oracle, that you want to get your data types correct. Now, having said that, let's explore a tiny bit further, because I had all the tochars fixed up. Drop the tables now, they're both created as integers. So data types are now in alignment. Populate them, gather some more stats, we're good to go. As I said, now that the data types are in alignment, we should be able to get a hash join, right? No, we're still back on the merge join. Why is this? We can see now in the notes section, I've eliminated all the tochars and the toNumbers. There's no data type conversion going on. However, there is still some functions being applied. This internal function. Now, we're not told what the internal function is, but the reason it's there is because we have to deal when it comes to membership and not membership with nulls. And if I recreate the tables, both with not null, then I know that there's always data in both sides of the subquery. Repopulate my data, explain plan, and there's my hash join. Okay, so we're good to go. Very, very important. Oh, did I create them wrong? Oh, I'm surprised I got toNumber there. That might be the wrong explain plan. I'll have to redo that demo. So the key thing is what really matters. Let me go back to my slides because we're almost out of time. The key things are, as always, in everything in terms of Oracle, please use the right data types. You always get punished in some way, shape, or form. We've done office hour sessions, I think, last month where we had things like nchars and varchars. Use the right data types when it comes to comparison. And always be careful of nulls, super important. Nulls and not in are not good bedfellows at all. And for once, I reckon we've finished on time. Thank you, everybody. It's always a pleasure to have you here. Thank you for those that ask questions. I love it when questions come in because it makes it a little bit more back and forth, and I always appreciate it. And generally, I find I always learn something as well because I get an interesting perspective from those people out in the field. That's the one thing. I almost miss working with Oracle. I don't spend as much time on customer sites as I would like to. And rest assured, the last 2 years, I've spent very little time on customer sites. Thank you once again for your time. Thank you very much for your participation. And obviously, we'll be back again next month with another office hours. If you have questions or particular things you'd like to hear or talk about, please just hit me up on Twitter, send me a tweet, and we'll see if we can slot it in. Thank you, everyone, and we'll see you all again next month. Bye for now.